I will be going through a predicted paper, paper number 1, the non-calculator paper. This has been put together by Third Space Learning. Do go and check them out. They've got tons of resources on their website. Get your pens, paper, everything that you need ready, and let's go into the first question. Right, let's have a look at this. Find the highest common factor of 64 and 80. Now, I'll be going through these questions, and if there's something that you need a bit more support on, then I'm sure I have a video for it on my channel. If you're using a web browser, then it's easier to do this. You can actually use the search function on YouTube once you're in my channel, and you can just put in the keywords for the topic that you're looking for, and then you can come to that video. And I will tell you, I'll try to remember to tell you whether I have a video for this or not, but most of the topics, I've got about 200 videos at the time of recording this, so there will be plenty of stuff there for you. Okay, so question number 1, find the highest common factor of 64 and 80. Now, your teachers, I should say, may have shown you different methods to do this. So my method may not be the same as yours or whatever you're used to, but just focus on the final answer. So if using your method, you come to this final answer, then that's good. All right. So I will be using here to break up 64 using the prime factors. Okay. So 80 and 64, I'm going to do that. Okay. So I'm going to be dividing by the prime factors. So 2 and 32. I circle the 2 because it's a prime number, and I break up 32 further. So that again, 2 and 16, circle the 2, continue doing that, 2 and 8, circle the 2, that's 2 and 4, circle the 2, and then 2 and 2. So how many 2's do I have? 1, 2, 3, 4, 5, 6. So that is 2 to the power of 6. Now we'll do the same thing for 80. So again, we can divide by 2 because it's nice and easy. 2 is a prime number. I can divide by 2, I can divide by 3, 5, 7, so on and so forth. All the prime numbers, all right? So 2 and 40, I continue with the 40, 2 and 20, break the 20 up, 2 and 10, break the 10 up, 2 and 5. And 2 is a prime number, 5 is a prime number. So how many 2's do I have? 1, 2, 3, 4, and 1, 5. So that's 2 to the power of 4 times by 5. Now, the question says, find the highest common factor. So what's common to both of them? As you can see, this one is just 2 to the power of 6, and this one is all of that. So this doesn't have the 5. Okay, so 5 is not going to be common. This has 2 to the power of 6, and this has 2 to the power of 4. So as a minimum, they both have 2 to the power of 4. So the answer would be for 2 to the power of 4. And what is 2 to the power of 4? 2 to the power of 4 is 16. That's 2 times 2 times 2 times 2. And that gives us 16. So the highest common factor is 16. Let's move on to the next one. So here we have question number 2. Lily has a bag of marbles. There are 3 different sizes of marbles. The pie chart shows information about the size of the marbles. Small marbles weigh 2.1 grams, medium marbles weigh 3.5 grams, and large marbles weigh 4 grams. Work out the total weight of Lily's marbles, or the marbles in Lily's bags. So where do we begin? Well, if you look at the pie chart, you can see that small has a quarter of the pie chart. And we know it's a quarter because of this right angle. That's 90 degrees. And as you know, in a pie chart, it adds up to 360. So 360 divided by 4 gives you 90. So this is a quarter, okay? So that means we have 1/4 of the marbles. So what is of the marbles? The total is 60. So 1/4 of 60. So 1/4 of 60 is 60 divided by 4. That gives us 15. So 15 small marbles. Okay, let's go and bank that. The medium marbles weigh 3.5 grams. So as you can see, it's 60 degrees angles. So that would be 60 out of 360, which is the total amount of angles in a pie chart of 60. Now let's simplify the 60 and 360. We can first of all divide by 10, so that cancels out the zeros. And then we've got 6 over 36, which can be further simplified as 1 over 6. And what does of mean? That means multiply. So it's multiplied by 60. Okay, so again, we're going to do 60 divided by 6. And what is 60 divided by 6? That gives us 10. So 10 medium marbles. Finally, the large marbles, they weigh 4 grams, and this part of the pie chart is the large marbles. Now, we don't actually have an angle for it, but large marbles is the rest of it, okay? So if we already know we've got 15 small marbles, 10 medium marbles, then the rest of it from 60 would be to add these up and take it away from 60. So large, let's do it here, would be add up 15 plus 10, which is 25, and take that away from 60. And that gives us 35 large marbles. Now, the question did talk about weight. So we have to work out the weight of all of this, all right? So if we do that down here, so for the small, we have 15 small marbles, each weighing 2.1 grams. So 2.1 grams. Now remember, no calculator, all right? So how do you do this without a calculator? The best way to do this is to do 15 times the 2, all right? Let's write this here. 15 times the 2, which that gives us 30. Let's just 30 grams. And then do 15 times by the 0.1. Okay, so 15 times by 0.1. And if you look at this, let's just zoom in here a little bit. If you look at this, you just do 15 times by 1, which is 15, and then add your decimal place. So no decimal places here, but 1 decimal place here. So in total, we have to give this 1 decimal place. So the decimal would have to be right between the 1 and the 5. So this is 1.5 grams. So the total of that would be to add both of them. So 30 plus 1.5, which is 31.5 grams. So that's the small. Okay, let's go and zoom out again. There we go. So that's the small. Now let's do the medium. So the medium, we have 10 of those, and they weigh 3.5 grams. So that will be 10 times by 3.5 grams. Again, we can do it the other way. So we can do 10 times by 3 first, which is 30, and then we can do 10 times by 0.5, and that gives 5. So let's add this up. So that's a total of 35 grams. So 35 grams is your medium. Finally, the large. So we know there's 35 large marbles. I'm going to multiply this by 4. So 35 times by 4. So how do you do this without a calculator? You could do 35 times 2 and then times by 2 again. So 35 times 2 is 70, and 70 times 2 is 140 grams. So that's your large. All you have to do now is to add all of this up. So for the first one, for the small, you got 31.5. Medium is 35, and large is 140. So let's go ahead and write this down. So start with the large one, 140 plus 35. I'm going to use a column method to do this, plus 31.5. All right, so we can put zeros here after the decimals to help us. So if you add all of this up, that gives you 5. Put the decimal in. 0 plus 5 plus 1 is 6. 4 plus 3 is 7. Plus the 3 is 10. So I'm going to put a 0 here. Carry the 1. Okay, I carry the 1 here. Some of you carry it right at the top, no problem. And then lastly, 1 plus all of that. There's nothing there, but you have to don't forget to add the 1. So 1 plus 1 is 2. So 206.5. So the total is 206.5 grams. So on to question number 3. Write 3.8 times 10 to the power of minus 5 as an ordinary number. We have this in standard form. So what does this mean? Let's go and zoom in a little bit. So we've got the minus here, which would mean that this is a 0 point something number, okay? And minus means that these numbers will go this way. How many steps? 5 times. All right, so look, let's look at the 3 as a marker. So 3 would go 1, 2, 3, 4, 5. 5 steps. So the 3 will end up right here, okay? And all of these spaces will be filled by 0. All right, so 0 point, so this one right there is 0. And then this one right there is a 0. So how many zeros do you have? 1, 2, 3, 4. So 1, 2, 3, 4. And then we have the 3 and the 8. Right? As the 3 was going like that, so was the 8. So the 8 is just going to be next to it. So the answer is 0.000038. Okay. On to part B. Work out 2 times 10 to the power of 2 times by 4.1 times 10 to the power of 5. Now remember, you're not allowed to use a calculator with this, all right? So just bear that in mind when you're doing this. Right, it's multiplying. Okay, it's not the addition or takeaway where you need to change the powers. All right, so you can just do 2 times by 4.1. So let's do that. So 2 times by 4.1. So we're going to do 2 times by 4, which is 8. And then we're going to do 2 times by 0.1, which is 0.2. So the answer to that would be 8.2. Okay, we've got the 8.2. Let's write it here. 8.2 times 10 to the power of something. Now, with these, all right, let's just do it here. So 10 to the power of 2. You're also going to use the indices rule. Okay, so 10 to the power of 2 times by 10 to the power of 5. What do you do when the bases are the same? You just add the powers. So 10 to the power of 2 plus 5. So 2 plus 5 is 7. So that gives us 10 to the power of 7. So it's going to be 8.2 times 10 to the power of 7. Our answer is in standard form. So just in case it's not, we might need to make some changes. But this number has to be between 1 and 10. And it is. So 8.2 times 10 to the power of 7. Okay, question number 4. Now, this question is going to be a little bit tricky because you actually need to see me physically do this. And I sort of need a camera on top of me right now. And obviously, I'm working on the iPad, so I can't really show you this as I would like to show you. All right. But I will try my best to explain this and explain all the steps so you know what you're doing. All right. So it says C is the point on the line AB. Construct the perpendicular to the line AB at the point C. You must show all your construction lines. So we want to be drawing a line like that. Okay. Now don't be getting your ruler out in an exam and just start drawing this line. Okay, because you have to show your construction lines. You want, even if you get it right, let's say it's dead on accurate, so perpendicular bisector of, not the bisector, but perpendicular construction line here. Okay, even if this is 90 degrees and the examiner don't see these construction lines, you are not gaining any marks. So don't even try that, okay? What you need to do is the following. You start from this position, you take your compass out and draw arc here and here. Now the same length, okay? This has to be the same length, okay? And you might be wondering, asking, how long does it have to be? It doesn't have to be a particular length, as long as it's away from that line, okay? And don't change it when you go to the other side. So do one here and one here. So I'm just gonna do one like that, okay? So I've drawn my arc. Next, what you do is you go to this point, okay? And you measure out your compass more than halfway, okay? But you don't do anything here, just measure it out, okay? The pencil part is right there, okay? And your compass pointy part is right there. Then what you do is you draw an arc like that, okay? Right? You can go through all the way if you want to, like that, it's not a problem. Or you can just go up there and draw the arc. So you draw the arc there like that, and you also do the same thing down here. It's from the same distance, okay? Now remember, I can't show you this accurately, so my one may look a bit funny, all right? But it's the construction lines need to be in the right place. So the distance between that and the distance between that should be exactly the same. You should not have moved your pencil and the pointy part of your compass, all right? Then pick it up, go to this point, okay? You don't need to measure anything else, okay? Go to this point and do the same thing. Don't need to go 2/3 or anything. It's the same measurement, okay? And draw an arc here and here. Like I said, you can follow these lines through like that. It's not a problem. So you could have done it for both of them, all right? But that's what you should have. So one arc there, one arc there. This is what you should have of your construction lines. And then all you do, guys, is just get a ruler and join a point through like that. Now, like I said, this isn't accurate because I'm doing it without a compass and I'm just showing you where the construction lines go. But what you should find, and you can measure this should be 90 degrees. And then you've done it correctly. Okay, so question number 5. These stem and leaf diagrams show some information about the number of hours the children from a class spent revising for their maths GCSE. So you've got the boys stem and leaf and you've got the girls stem and leaf. Right? And if you read the key, it says 1/1 represents 11 hours. So this right here, that means 34 hours. Okay? This right here means 1 hour. Okay? This right here means 13 hours. Compare the time the amount of time spent revising by the boys to the amount of time spent revising by the girls. Right, so we need to get some data from here. What kind of data can we work out from a stem and leaf diagram? We can work out the median. What is the median? The median is the middle value. All right. So if we calculate the median for both boys and girls, we can see that. All right. So let's see how many pieces of data there are, how many boys there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 boys. So to work out the median for the boys, we're going to do 19 plus 1 divided by 2. And that gives us 20 divided by 2. So we're looking for the 10th value. The median is not 10. All right. We are looking for the position of the 10th value. So where is that? Let's start from the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the median? It's not 1, it's 21. All right. So it's 21 hours. That's the median for the boys. Let's work out the median for the girls. So median for the girls. So let's count how many pieces of data there are for the girls, how many girls there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 girls. So to work out the median, it's going to be 17 plus 1 divided by 2. So that's 18 divided by 2. You're looking for the 9th value. Right? Once again, the median is not 9 for the girls, it's the 9th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 15. So 15 hours is the girls' median. So as you can see from this alone, the boys' median is higher. So let's write that down. The boys' median, average amount of time spent revising, is higher than girls. Now that's probably 1 mark. This question has 2 marks, as you can see. So you try to give something else. You can give the range, okay? The range is the spread of the data, how much is spread out. So for the girls and the boys, let's work out the range. Let's start with the boys. So the range for the boys. So what is the range? It's the highest number for the boys, which is 42. Take away the lowest number, which is 2. So 42 take away 2, it is 40. So the difference between the maximum amount of hours spent and the least amount of hours spent by the boys is a difference of 40 hours. All right. Let's do that same thing for the girls now. So the girls' highest is 34 and the lowest is 1. So it's going to be 34 take away 1, which is 33. So the boys' range is higher. So the boys' range is higher. Okay, and that should give you your 2 marks. Question number 6. Oscar has designed a game. Oscar has a set of 10 cards numbered 1 to 10. A player wins the game if they pick a card that is a prime number. Olivia picks a card. Find the probability that Olivia wins. All right, so the winner is determined if they pick a prime number. So what are the prime numbers in a set of cards which are numbered 1 to 10? So we have 2, we have 3 as a prime number, we have 5, and we have 7. So these are the prime numbers between 1 and 10. Okay, so how many prime numbers are there? There are 4. So 4 out of the probability of winning is 4 out of the 10 cards. Okay, 4 out of 10. So the probability that Olivia wins is simply the probability of someone winning, which is 4 out of 10. Now, Oscar will charge 50p to play the game. The prize for winning is £1. 200 people play the game. Work out an estimation of the amount of money that Oscar will make. So let's figure out how much Oscar will make, his takings, without profit, just takings for the game. If 200 people are playing this game and they each pay 50p, that would be 200 times by 0.5 pounds. Okay, so that's 200 times by half, really, which is 100 pounds. So that's how much money he takes in. Okay, he collects. Let's write this down. He collects that amount. Now, the price for winning is £1. What's the probability that someone wins? Well, earlier on, we saw that the probability of someone winning is 4 out of 10. If there's 200 people playing, then the expected amount of winners will be to multiply 4 over 10 by 200. And now we need to work this out, and that will tell us how many times someone will win. Without a calculator, of course. All right. So shall we simplify this fraction first? So 4 over 10, that can be simplified to 2 over 5 and times by 200. And then what we can do, we didn't even need to do that. We could just do it anyway, but it's probably easier. So we just do 200 times by 2, which is 400, and 400 divided by 5. Now, the best way to do 400 divided by 5 is just ignore this 1 0. Do 40 divided by 5. And you know 40 divided by 5 is 8. So you can write down 8 here and then add that 0 that you are hiding. So 80 wins. So there might be 80 wins. If there's 80 wins and each person gets a prize of £1 for winning, that would be £80, right? So you take away £80 away from the total amount collected. So that would be 100, take away 80, and that would leave Oscar with a profit of £20. And that's how much money he will make. So question number 7, write down the exact value of sine 30. Now some of you may know the answer to sine 30 and you can just write that down, no problem. But those of you that don't know, and this is something that you do need to go and look up, sine 30 and sine 60 and cos 30 and all of that comes from two different triangles. And the one that we are interested in is this one, which uses 30 degrees up here, 60 degrees here. This is 1, this is 2, and this is root 3. So sine is obtained. So you're looking for sine 30. So this side here will be your opposite. And this is your hypotenuse. And this is, of course, your adjacent, which you don't need. Sine comes from SOHCAHTOA. And you're looking for just sine theta is equal to opposite over hypotenuse. You're looking for sine 30. So sine 30, opposite that is 1. So sine 30 opposite that is 1 divided by the hypotenuse. The hypotenuse is 2, so 1 over 2. So sine 30 is a half. That's what it's equal to. Part B of this question, it says A, B, C, D is a kite. B to C is 6 centimeters. A to C is 10.4 centimeters. Work out the area of the kite, A, B, C, D. Now, there are two different methods I could actually show you how to answer this question. But let's just go with one of them, all right? So the first thing that I want you to do is have a look at your diagram in a little bit more details. Figure out where all the necessary shapes that you know the area for are. You can see that this kite consists of two big triangles there. And then you've got this line going across. Some of you may even look at this as a triangle as well. That's not a problem. But we are going to just focus right here, okay? On this side right there. So if you look at this, this is a right angled triangle. All right, so let's quickly just draw this right angled triangle. So this is a right angle. We know that to find the area of a triangle, we do base times height divided by 2. So this is 6 centimeters. This here is 30. Let's call this x because we want to know what the base is. So how do we find this x? So if we have this length, we can do base times height divided by 2. Base is x, height is 6. It's a perpendicular height, so great. We can work out the area of this triangle right there, and then we can times it by 2 because this is identical. All right, and that will tell us the area of the full kite. All right, so how do we find this? So once again, let's label this. Let's label it according to our angle right here, which is 30 degrees. So this will be the adjacent side, and this will be the opposite side. So what in SOHCAHTOA uses adjacent and opposite? Well, that's tan, right? So it's going to be tan theta is equal to opposite divided by the adjacent. So tan is 30. So tan 30, I mean. So theta is 30 is equal to the opposite. What's the opposite? Is 6 divided by the x. So if you rearrange this, and I've got a video for this on the channel, go check out Trigonometry. Okay, if we rearrange this, it's going to be x is equal to 6 over tan 30. Now remember, no calculator, all right? But we can go back to that diagram I did earlier up there for the first part, and we can work out what tan 30 is. All right. Now, this 30 degrees, let's go in here. What is tan 30? Well, tan 30 is going to be whatever opposite is, because opposite that is 1, and divided by the adjacent, which is root 3. So it's going to be 1 over root 3. So that's what tan 30 is. So we know that tan 30 is equal to 1 over root 3. So we can replace in here root 1 over root 3. So that will be x is equal to 6 over 1 over root 3. And this simplifies to, all that happens is this goes all the way to the top and multiplies. So it's going to be 6 root 3 over 1. We don't need to write that. So x is equal to 6 root 3. Now that we have found x is equal to 6 root 3, let's work out base times height divided by 2, the area of that triangle. So the area of that triangle is base times height divided by 2. So it's going to be, in fact, it's probably easier to use this version, half base times height. Okay, but it doesn't matter, you could use either. So half times the base, which is 6 root 3, times the height, which is right here, 6. Okay, so what happens here? Well, let's just do this one first. So half times the 6 is 3. So 3 times by the 6, okay, is 18. So that would be 18 root 3 centimeter squared, because we worked out an area of a triangle. So all I've done is I've worked this out here. Now I've got 2 of these guys, so I'm going to multiply this by 2. So that would be 2 lots of 18 root 3, and 2 times 18 is 36, so it's 36 root 3. Oh, and don't forget centimeter squared. Okay, oh, it's there anyway. Let's move on to question number 8. Write down the value of 11 to the power of 0. Anything to the power of 0 is 1, so that's your answer. Find the value of, let's zoom in because this might be hard to see. Find the value of 125 to the power of 2 over 3. So the 3, it does a cube root, so the cube root of 125, and then the 2 powers. Okay, what's the cube root of 125? It is 5, so it's 5 squared, and that gives us 25. So that's the answer. Part C, find the value of 3 to the power of minus 2. When you see a minus in the power, it's just 1 over that number and the positive version. So 1 over 3 to the power of 2, and that is 1 over 9. So that's your answer there. Question 9, Sheila is baking cupcakes. Her recipe makes 12 cupcakes, and it's given you all the ingredients and their measurements next to it. Sheila has plenty of sugar and flour, but she has only 300 grams of butter and 6 eggs. Well, the only isn't there, but I added it in there just to emphasize it for you, okay? What's the maximum number of cupcakes that Sheila can make? Now, sugar and flour, all good, all right? We don't need to worry about that. Let's look at the butter and eggs. Now, if she can make 12 cupcakes using these ingredients, we need to know what's the maximum she can make with 300 grams of butter, right? So how do we do this? Well, the simplest way is literally to just do 300 grams divided by 120 grams and work that out. So we can cancel the zeros here, and we've got 30 over 12. 30 over 12, how many times does 12 go into 30? 24, so that's twice. Left over is 6 over 12, so 2.5. Okay, 6 over 12 is a half, so 2.5. So she can make 2.5 lots of 12 cupcakes. Okay, so 2.5 lots of 12 cupcakes. Okay, we'll come back to that in a second. Let's look at the eggs. So 2 eggs makes 12 cupcakes. If she's got 6 eggs, we're going to do 6 divided by 2. That is 3. So she can make 3 lots of 12 cupcakes. So 2.5 lots she can make using the butter that she has, and 3 lots of 12 using the eggs. All right. Now, obviously, you can't make 3 lots because this only goes up to 2.5. She hasn't got enough butter. So we have to go with the bare minimum, which is 2.5. So she can make 2.5 lots of 12 cupcakes. So how do we work that out? So we do 12 times by 2, which is 24, and then we do 12 times by 0.5, which is 6. So she can make a total of 24 plus 6, and that is 30. So she can make 30 cupcakes using her ingredients. All right, so There's a question, take it all in. There are other ways that you could have done this. This is not the only way, okay, but this is just one of the ways. Right, if you need to take a break, guys, pause the video, go for a walk somewhere around the house. All right, you can't get all of this into your heads one after the other because it's going to go in one ear and come out the other. So go ahead and take a break. All right, so question number 10. Given that a over b is equal to 7 and b over c is equal to 5, find an expression for a in terms of c. So the questions are going to start to go up in difficulty now, if they haven't already. All right, so we need to find a way of expressing a in terms of c. We need to find a way of integrating or equating these two expressions or equations with each other. All right. Now, what do you notice? Both of them have a b in it. Okay. So let's find an expression for b. So if we use the first one, we got a over b equals 7. If we multiply the b on the other side, so we get a is equal to 7b. Okay, we'll just leave that for now. And now let's focus on this one. And we'll do the same thing. So we can have b over c is equal to 5 currently, and then multiply the c onto the other side. So we get b is equal to 5c. Now the question says express a in terms of c, which means the b has disappeared. All right. So in order to make the b disappear, you've got to plug this b into here. All right. And that would make the b completely disappear because it would be represented in terms of c. So let me show you what happens there. All right. So you're going to plug this right there. So therefore, a would be equal to 7 bracket 5c. This is where b used to be. Okay. But it's not there anymore. It's just 5c because on the other expression or the equation, it says b is equal to 5c. So I've replaced it. All right. So now I have a is equal to, let's multiply this bracket out. 7 times 5 is 35. So a is equal to 35c. And there I have expressed a in terms of c. So a is equal to 35c. Question 11, you've got a table, the first 80 customers visiting the shop. This is the amount of money that they spent. Complete the cumulative frequency table. All right, so this looks like a cumulative frequency diagram that we're going to be doing soon. How do we fill this table in? We add all the frequencies. All right, so the first one is 8. So 8 goes in here. Then we add the 12. So 8 plus 12 is 20. And then we had the 19 next, and then we had the 17, 13, so on and so forth. So 20 plus 19 gives us 39. 39 plus 17 gives us 56. 56 plus 13 gives us 69. And 69 plus 11 gives us 80. So that's all done. Now we're going to probably need this, so I'm going to just quickly make a copy of that. And here it says on the grid below, draw a cumulative frequency graph for your table. So let's just paste that in there. So this is what we've done earlier. Okay, so I've just put that little table up at the top. I don't know how well you can see the bottom and the axis here. If you can see the markings, or hopefully you can, but I'll zoom in and out so you can see it. So where do we plot it? A mistake that students make is when they plot like this one, for example, they know it has to go, 8 somewhere on the cumulative frequency, right? They know that. But it's where they plot on the x-axis. One of the common mistakes people make is they plot in the middle. All right, they plot in the middle. So they go between 0 and 20 and they plot at 10. No, you have to plot at the upper end. Okay, so at the 20, at the 40, at the 60, 80, 100, 120. All right, so we're going to plot this 8 on 20 on the x-axis. All right, so look, let's go down here. So 20 here. Okay, and then go and find where 8 is. Now, you have to know what these squares represent as well. So from here to here is 10, as we're told here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each square is 1. So that means 8 is going to be right there. So we can plot 8 right there. Okay. Now, that's the first one done. The next one is going to be 20 at 40. So that's going to be 40 on the x-axis and 20 right there. After that, we're going to have 39 at 60. 39 at 60. So at 60 on the x-axis, go and find 39 just under 40. And then we're going to have 56 at 80. So 56 at 80, 51, 2, 3, 4, 5. Oh, this one's just zooming in a little bit. 1, 2, 3, 4, 5, 6. Right there. Then we're going to have 69 at 100. So 100 here and then 69 right there. And then finally, we're going to have 80 at 120. So 120 up to 80 right there. Now, after this, you need to draw a line or a curve going through it, okay? And it's a line or a curve, it doesn't matter. Used to be years ago just curves, but the exams are allowing lines as well. So, you know, you can draw lines. Let me draw lines, okay? There we go. So do this with your ruler, obviously. All right, I've got a special thing on my iPad that allows me to do this. So don't you do this freehand, please. And all right, you notice here I'm going down to 0. All right, the reason I'm going down to 0 is because if you look at the table, right, it goes down to 0. Okay, don't worry about the higher one though. Yeah, it just goes down to 0. All right. Now, what do we do after this? It says on Sunday, and there's always a part after this. Okay, so do pay attention. On Sunday, the median spend of the first 80 customers was £25. So what's the median? The median is halfway. Half of the total number of customers. It's out 80, so halfway is going to be at 40, okay? It says the median spend was £25 on a Sunday, okay? On Sunday. Compare this to the median spend of the first 80 customers on a Saturday. So this cumulative frequency that you've done, right, is for the customers on a Saturday. All right, so this represents Saturday. So let's find our halfway point. So I said it's going to be at 40. So I'm going to get my ruler, draw a line at 40, and then wherever it hits my line, so can you see it hits my line here, right? I'm just going to read down, okay? And it doesn't have to be pinpoint accuracy here, guys. Remember, because you drew your own line, all right? So I'm going to go down, and as you can see, it's about £60. All right, so my median on a Saturday, is £60. So what can you say? Well, you can see on Sunday, the average median people spent was £25. Saturday, much higher. So Saturday, people spent more than Sunday. Okay, sorry about the handwriting. I do write neater than this, but obviously I'm trying to get through an entire paper, and you guys have got such a short time span. If I don't make this attention span, if I don't make these videos short, guys, you guys just lose interest and then you switch off, and then obviously YouTube algorithm don't like that and they won't suggest it to somebody else. So this is why I've got to sometimes rush my explanations, which I sometimes find isn't very helpful, because I'd rather you guys understand and take time in understanding things. So allowing me to sort of give more explanation and understanding behind things. But anyway, let's move on. Talking too much. All right. So question 12. Here are 3 pentagons. This is a good question. This is quite common actually. These have been coming up recently, so pay attention to this. All right. So let's read. The area of pentagon B is 50% greater than the area of pentagon A. All right. What does that mean? That means from pentagon A, the area is multiplied by 1.5 if you use the multiplier idea. Okay, that's 50% greater, right? It's multiplied by 1.5. Then it says the area of pentagon C is 40% greater than the area of pentagon B. That means to go from pentagon B to C is 40% greater. So that would be a multiplier of, remember, 40% increase. So it's going to be times by 1.4. All right, that's what we have. So let's go back to the question. It says write down the ratio of area A to the ratio of area B to the ratio of area C. So in other words, A, B, C, we need to find that ratio. Now, let's go back to A. Do we know its area? No, we don't. But let's give it something. All right, let's give it an area. Let's call it X. So if the area of A is X, the area of B, remember it's going to be multiplied by 1.5, is going to be 1.5 times X. So 1.5X. And if the area of C is 1.4 times more, okay, 40% more, it's going to be multiplying this by 1.4. So the area of C is going to be 1.5x multiplied by 1.4. That simplifies to, you just need to do 15 times 14. Okay, so you can remember it's a non-calculator paper. So 1.5 times 1.4 is the same as doing 15 times 14, by the way, all right? So do 4 times 5, you know, that gives us 20. So 4 times 1 is 4. Add the 2, that is 6. And then do 1 times 5. Oh, not that yet. Add a 0, don't forget. 1 times 5 is 5. And then 1 times 1 is 1. So you got that. So let's collect that together. So that gives us 11. Carry the 1 and add the 1 again. So that's 2. 210. Now, remember, it was 1.5 and 1.4. So total of 2 decimal places. Yeah, we have 1 decimal there, 1 decimal there, 2 decimal places. So in order to give this 2 decimal places, all right, it's going to be right there. Okay, so the final answer is going to be 2.1. We don't need the 0, x. All right, that is the area of C. So if we put those values in now, so A, we put it here, B, we put it here, and C, we put it here, we get this x, 1.5x, and 2.1x. Okay, now we can do without the x's. We can just replace, if we divide by x's, all right, that gives us 1, 1.5, and 2.1. Now we want the area, so we want the ratio, sorry, in its simplest form. Currently, these are all in decimal form, so I want to make them whole numbers. How do I make them whole numbers? I can multiply everything by 10, and that will give me whole numbers. So that would be 10, that would be 15, and that will be 21. And that's it. That's my final answer. All right, so question number 13, write 6 over x plus 2 plus 5 over x minus 1 as a single fraction. Right, where do we begin? We need to have the same denominators. Easiest way to do this is to cross multiply. So the x plus 2 multiplies with the 5 here, and the x minus 1 will multiply there. And the bottom 2 can multiply with each other. So that gives us x bracket x minus 1 plus 5 bracket x plus 2 all over x plus 2 and x minus 1. I do have a video for this on the channel. Go and check out Algebraic Fractions. Right, so we expand the top. So 6 times that, 6 times that, that times that, blah, blah, blah. So let's do that. 6x minus 6 plus 5x plus 10. And leave the bottom as it is. You don't need to actually expand that out. You can do if you want to, but it's not necessary. And then you just collect the like terms from the top. So you got 6x plus 5x, that gives us 11x. And then minus 6 plus 10, that's 4, positive 4. And that's x plus 2 over x minus 1. And that's your final answer. Okay, next part, part B, simplify fully. The top here, you can see the difference of 2 squares. So it's going to be a quadratic factorizing. So you're going to have x minus 4 and x plus 4. And the bottom one, you're going to do x, and you want something 28. So that's going to be 7 and 4 plus 4 and minus. If you need help with factorizing, all right, do go and check out the cheat method for factorizing. Okay, it's a really good video that I've got, really good technique that I actually use in that. Okay, right, anyway, back to this. We can cancel out the x plus 4, and that leaves us with x minus 4 over x minus 7. So that's your answer. Question number 14, inequalities, graphical inequalities. I've done a video on this very recently, so do go and check that out if you need further help, where I explain things in a little bit more detail. All right, so in this video, for this question, I'm not going to go into too much detail. You can refer to that video, but I will do my best to explain everything for this question. All right, so label the region R. You've been given all these inequalities. Step number 1, if you don't have y on its own already, like you have in these 2 examples, then you need to. Okay, so this one, you need to rearrange it so y is on its own. Okay, so you can do that by taking the 2x over to that side. That gives us 6 minus 2x. So now you have y on its own. I'll explain why you want y on its own like that. Okay, now you're going to draw all of these graphs, all of these lines. Okay, in your head, just imagine this is an equal sign. Okay, so imagine you're drawing y is equal to 1. Where is y is equal to 1? Y is equal to 1 is a straight line going like that. All right, so let's draw a straight line going like that. In fact, let's draw it using different color. Okay, that is the line y is greater than 1. Now, very quickly, does my line have to be dash or solid? Okay, does it have to be a dash line or solid line? If it is just greater than and not equal to, all right, just greater than, then you draw a dotted line. So there you go, guys. I've added some dashes to my line, as you can see. That's all good. Now I'm going to draw this one. So what does this look like? All right, now you might need some practice of straight line graphs, drawing straight line graphs. So the best way to do this is to start at the y-intercept, in this case, which is 6. We've got a negative gradient, so we know it's going to be a line going down, and the gradient is 2. All right, so you start at 6, let's mark it, and then you go down, and you have to give it a gradient of uh, 2. Okay, so that means on the y, you're going to go down by 2. Okay, so going down by 2 from there is 1, 2, and then you're going to go across by 1. Right, now going across, by the way, look at this graph, how it's drawn. From there to there, to go 1 this way, you need 4 squares. But to go down, you only need 2 squares. All right, so keep an eye on the markings, on the numberings. All right, so from 6, you go down by 2, across by 1. So you're right there. Okay, I'm going to draw that right there. Do it again. Down by 2, across by 1. Okay, right there. And I've done this on my video in detail, so you can see it there. Okay, down by 2, across by 1, right there. And that's all we need, because we're just going to draw a line through it anyway, a straight line like that. And also I do explain in my video as well to go back as well, like that. Now, is my line dotted or solid? This one is equal to, right, it's less than and equal to, so it's going to be a solid line, which means that we can have solutions on it. All right, finally, the last one, y is less than 2x plus 3. So we're going to start with the y-intercept at 3, and we're going to have a positive gradient going like that, a gradient of 2. Okay, so let's go ahead and draw that line. So we're going to start at 3, and we're going to go up by 2 and across by 1. So right there, that's our second one. Up by 2, across by 1. That's our second mark, or third mark rather. Up by 2, across by 1. It was off the graph anyway. So we're going to draw a line now. So from there to there, let's draw our ruler and go backwards as well. There we go. Right, now comes the part of shading. Now the question says, by shading, show the region or label it. Okay, what I do is this. So let's look at this line again here. Okay, it says you want the values of y greater than 1. If the value of y, if y is greater on the greater than sign, then you want above. You want above the line. Okay, you want this part of the line. So I'm going to shade out the part that I don't want, which is below the line. Okay, I don't want below the line. So because y is greater than 1, okay, I want above the line. I don't want below the line, right there, below that line. I don't want that. So I'm going to shade that out. Look, just focus on that line that you're focusing on right now, and just shade across like that. Okay, and do the same for the other two. So here, y is less than, all right? So let's look at that line. Oh, I didn't even label it, by the way. So let's quickly go and label that line. So it's this line here, y is less than 6 minus 2x, and the other one is y is less than 2x plus 3. Okay, so now I'm looking at this line. I want the values of y less than. So if it's less than, I want below the line. I want below the line. I don't want this side of the line. Okay, I don't want this side of the line. So I'm going to shade that out. So here we go. I'm going to shade this all out. Go on to the last one. Y is less than. And by the way, this is why I wanted y on its own, because I can just look at what is y. Okay, this wasn't helpful for me in that form. I want it like that. Okay, so anyway, y is less than. So let's look at that line, which is right there. We want less than. Okay, below the line. Less than means below the line. Okay, I want all of that. I don't want all of this. So I'm going to shade that out. Look, I'm going to shade it all out. Okay, can you see what I'm left with? I'm left with this region right here. Yeah, look. I can shade that in. That is what I want. And it's been left unshaded, ready for me to come and write an R. That's the region I want. Okay, and that's this question done. All right, question number 15. This shape has been made by removing a small semicircular area from a larger semicircle. So let me show you what's going on here. Let me just draw this. All right, you've got this, and you've had this removed like that. Okay, so let's go ahead and write down those measurements, those lengths that we know. So we know that from here to here is 10. Now, if you've removed 4 already, and this is symmetrical, all right, you've removed the 4 from here to there, all of that has to make 10. That means on either side, you're going to have to make up, using both sides, 6 centimeters, because 4 plus 6 is 10. So it's going to be 3 centimeters each, all right? So let's just quickly make a note of that. Now the question says, work out the perimeter of the shape, given your answer in terms of pi. Pi because obviously it's a non-calculator paper. So the perimeter of the shape we're talking about is this length here, plus this, plus that, plus that. All right. So we need to work out the circumference of this semicircle by using a full circle and then dividing it by 2. All right. So I'm going to do it for both of them because the circumference of this one right there is the same thing as that. All right. So we need to work out the circumference of both of these shapes, these semicircles. All right. So let's do the small one first. So we know the diameter of the small one is 4 centimeters. We know the diameter of the large one is 10 centimeters. Remember, we're going back to this one like that, okay? And that's 10. How do you work out the circumference? You do C is equal to pi times diameter, right? So it's going to be pi times 4, but you're going to divide that by 2. Why? Because you're not doing the full circle. This is for the full circle. You're doing it just for that, all right? So you're going to divide it by 2. And then if you simplify that, you can cancel out the 4 and the 2. That ends up being 2 pi. So the small one's circumference, if you want to call it that, or the arc length really, is 2 pi. And we'll do the same thing for the larger one. So pi times the diameter of a full circle, but this one is going to be pi times by 10 and divided by 2. Once again, we're going to simplify this. So 10 and 2, so we're going to end up with 5 pi. So the circumference or the arc length of the larger one is 5 pi. So we've got this, we've got that, we just need to add the 3 on both of them, all right? And the perimeter will therefore be 2 pi plus 5 pi plus 3 plus 3. And that gives us 7 pi plus 6, and that's in centimeters. So that's your answer. Question 16. Dave wants to find an estimate for the number of fish in a lake. On Monday, he catches 80 fish. He puts a mark on each fish and returns it to the lake. On Tuesday, he catches 120 fish. He finds that 6 of these have been marked. Work out an estimate for the number of fish in the lake. I have got a video on capture and recapture method, so you can go and look that up if you want to practice more on this. All right. So let's start with the first one. On Monday, he catches 80 fish out of the total number of fish in that lake. We don't know what it is, so we're going to call it N. On Tuesday, he catches 120 fish. He notices that 6 of them have been marked. So 6 out of 120 fish that he catches. So in order to work out an estimate, all we got to do is equate these two together. Okay, because it's from the same lake, so we can equate them. So 80 over N is equal to 6 over 120. And then simple, just find what N is by solving this. All right, so we're going to multiply the N up here. We're going to multiply the 120 up there. So it's going to be 80 times 120 is equal to 6N. 8 times 12 is 96. And then we add the 2 zeros. So we've got 9,600 is equal to 6N. Now we need to do 9,600 divided by 6. We're going to have to use long division for this one. So how many times does 6 go into 9? It goes in once. The remainder is 3. How many times does 6 go into 36? It goes in 6 times. And then we've got the zeros left over. So we're just going to add those zeros along. Okay. So it's 1,600. So N is equal to 9,600 divided by 6. N is equal to 1,600. There you go. So there's 1,600 fish in the lake. Question 17. Use circle theorems to show that A to C is a diameter. Now there are various circle theorem rules that you need to know, or theorems that you need to know. If AC is a diameter, what do we know about one of the theorems? It is that angles in a semicircle equal 90 degrees. So this angle here has to be 90 degrees. If we can prove that this angle right there is equal to 90 degrees, then we know that AC is a diameter. We've proved it because these two lines that come off the diameter or come off these 2 points to make this angle would make that rule. Okay, so let's focus on what is this angle right there. Okay, let's just keep our focus on that. So if we use one of the other theorem rules, which is angles subtended by this arc, okay, look, they make an angle right there, and they also make an angle right there. Okay, this would mean that this angle and this angle are the same. So that's one of your rules. Okay, that angle CAD. So let's write down CAD is equal to 23 degrees because angles in the same segment. Okay, that's, you have to give reasons. This question doesn't actually ask you to do that, but it will do in an actual exam. It would say give reasons for your answer, and that's the examiner expects that. Okay, so that's 23 degrees. Now look at this. See that? You've got a little triangle there. So let's draw that triangle so you can see a little bit more clearly. So that's C, that's D, and that's A. We just found this is 23. We've been given this as 67. Let's see what this angle here is. So what is ADC? We know that angle's in a triangle, add up to 180, right? So it's going to be 180 minus, let's add up these two. So that's 67 plus 23. And if that is 90, then that means this angle here would be 90, and therefore AC would be a diameter. Now 67 plus 23 is equal to 3, add the 70 plus the 20, 70, 80, 90. So that's 180 minus 90, and therefore we have 90 degrees. So this angle here is 90 degrees, and therefore AC is a diameter. All right, and don't forget to give the reason here. Angles in a triangle are equal to 180. All right. Also, it's worth mentioning that angles in a semicircle is equal to 90 degrees as well. So you might want to put that down as well. Right, move on to question number 18. Show that this can be written in the form a root 3. And there's lots going on here. Let's zoom in here. So what we want to do is we want to end up with a surd of 3, root 3. Okay, we want to end up with only root 3. So it means that we have to break up root 60 and root 15. All right, possibly root 15, we'll see. All right, let's start with root 60. Let's break it up. So we want to divide by the largest square number that goes into 60. The largest square number that I can think of that goes into 60 is root 4 and root 15. That gives us, so that becomes 2 root 15. So I can go back in here and I can replace that with 2 root 15. So that will be 2 bracket 2 root 15 minus root 15 over root 5. Now if you expand this out, what do you get? You get 4 root 15 minus root 15 over root 5. Now these are the same. All right, that means I can add these. So it's 4 minus the 1. We don't need to write a 1, but there is a 1 here. So what is 4 minus 1? That is 3. So that will be 3 root 15 over root 5. Now, does it look like what the question wants me to have? No, it doesn't. We have root 3 in the question, and I have root 15 and root 5. So that means I need to do something else to this. And that something else is to rationalize. Okay, I need to rationalize this. Now, if you remember what is rationalizing, I do have a video for this. I have lots of videos on Surds, so do go and check that out. Rationalizing is to multiply the top and the bottom by the bottom denominator. In this case, root 5. So that would be 3 root 15 times by root 5 over root 5 times root 5. So what does the top give me? So that would be 3 root, now 15 times 5, that's the only one I need to worry about. Okay, 15 times 5 is 75. And the bottom, root 5 times root 5 is just 5. Now, I still don't have what I need. That's because I need to break up 75 now, just like I did before. Okay, so root 25 times root 3 is 75, and root 25 is 5, and 5 root 3. So 75 can be represented by 5 root 3. So going down here, I have 3 bracket 5 root 3 over 5. So all I've done is replace root 75 with that. Okay, and I'm going to expand this out now. So that's going to be 15 root 3 over 5. Now 5 and 15, they have something in common. They can both be divided by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. So my final answer will be 3 root 3. And look, I have it. Okay, so A is 3. Question 19, given that x squared minus 6x plus 15 is equal to this, find the value of A and the value of B. Now you can see that this reminds you of completing the square. All right, so we take this and we complete the square. So how do we do that? How do we complete the square? You take the coefficient of x, all right, and you divide it by 2. So you put that in a bracket. So what's the 6 divided by 2 is 3. So it's minus 3 squared. And then you take that away, squaring it, and then you add your 15, which is hanging along. I've got complete the square videos. Do go and check it out if you need more help on that. All right. Then we just tidy up x minus 3 squared, and that gives us, now be careful here, this alone gives us minus 3 squared, which is a positive 9. But the negative outside is waiting for that positive 9, and it makes it negative again. All right. So it's minus 9 plus 15. And then we just need to do the minus 9 plus 15 part. So minus 9 plus 15 is positive 6. So that's your final answer. Okay. So you've got it into this form right there. Now, it says write down the coordinates of the turning point. Now, this is something that you need to know. Minus PQ. So your value of P is actually here. In this case, it's actually using A and B, but usually they do use P and Q instead of A and B. So your value of P is here, and you just need to use the opposite sign. So here you got negative. So opposite of negative is a positive, so positive 3, because this minus is a constant in there. And the Q is as it is. So it's a positive 6, so 3, 6 is your coordinate. Explain how this shows that there are no solutions to the equation. I mean, this is really going into the A-level realm right now, okay? But you could say a number of things, but the easiest way to show you this is actually to draw a graph. This graph is a quadratic graph. Why? Because it's a quadratic right there. And it would look like something like this. So there. And this turning point is your 3, 6, okay? So 3 on the X and 6 on there. Now, as you can see, this line doesn't come and cross the x-axis. And because it doesn't cross the x-axis, it means that it doesn't have solutions. All right, so it doesn't cross the x-axis would be enough. Sorry, I should write x-axis would be enough to get you that 1 mark. Okay. Question number 20. The function f and g are such that f of x is equal to this and g of x is equal to that. Work out the inverse of f where you put 44 in for x. Okay, so this. Now the first thing we want to do is work out the inverse. What is the inverse of f of x? We take this, we write it with a y instead of an f of x. So y is equal to 3x plus 2. And then we make x the subject. All right. I've got a video on functions. Go check it out if you need help. So we get rid of the 2, take it to this side. So that will be y minus 2 is equal to 3x. And then we divide by 3. So therefore, x would be equal to y minus 2 divided by 3. So we write it as this now. F of inverse of x is equal to, instead of a y, we go back to the x's. So x minus 2 over 3. Okay, so that's the inverse. But the question asked me to put in 44, where the x is. Okay, so where my x is, I put in 44. So that will be 44 minus 2 over 3. No calculator, remember. So 44 minus 2 is 42, and 42 divided by 3 is 14. So your answer to f of inverse 44 is 14. Part B, solve gf of x is equal to 0. So let's go ahead and find what gf of x is. So we're going to find gf of x first. What does that mean? It means you get f and you put it into g. All right. So f is 3x plus 2. We're going to put it into g wherever we see an x. All right. So that would be in a bracket 3x plus 2 squared plus, now x, we see an x again. So again, we put our 3x plus 2. Okay, that's what we have. Now, some of you may be tempted to expand this bracket. All right, you can do it now. You can do it later. It's up to you. But since we're going to make this equal to 0 anyway, we know that we have to do that because we have to solve to find the value of x. All right, so we can put that 0 right there. So let's go ahead and expand that bracket. So it's 2 brackets. All right, so this bracket is just this one, guys, okay? And this is that, okay? So we're going to expand that out. That's 3x times 3x, which is 9x squared. 3x times 2 plus 6x. 2 times 3x again is 6x. And then 2 times 2 is 4. And then we have all of that from this bracket. Collect all the like terms, and this is equal to 0 as well. Collect all the like terms, so you've got 9x squared. You have 6x, 6x, and 3x. So 6 and 6 is 12, plus 3 is 15. So plus 15x. And the 4 and the 2, that gives you 6. And you've got that. Now, you need to factorize this. But what you can do to help you is you notice that all of these are divisible by 3. So you can divide by 3, okay, to make it easier for you. So that will be 3x squared plus 5x plus 2 equals 0. And using the AC method or whatever method you're comfortable using here, guys, you need to factorize this, all right? So that will factorize to 3x plus 2 and x plus 1 equals 0. If it's this one, then obviously x is going to be equal to minus 2 over 3. If it's that one equaling to 0, you're going to have x is equal to minus 1. And these are your two solutions. Right, on to the last and final question. This is a bit of a mad one, so you need to pay careful attention to this, all right? Question 21. The top of a pool is horizontal. To begin with, this pool is empty. Water flows into this pool at a rate of 20 liters per minute. Water flows into the pool for 20 hours. It's given us this conversion here, and it's asked us to find the depth of the water H measured at the deepest point of the pool after 20 hours. Right, what's happened? We know that water comes in here, fills up this pool. This H that you can see on the diagram is a height. We don't know how high it is, okay, how high it's gone. So I'm going to quickly just draw a diagram just to help us out. So let's draw this pool using our H. So this is our H. You know that it goes up here like that. Got that. Okay, so all I've done is drawn this. Okay, we know that from here to here is 2 meters. We know that this is 1.2 meters. Okay, we got that here, and that 2 meters is right there. Let's work out the volume of the water after 20 hours. So the volume of water after 20 hours. Okay, so we know that water goes in here at a rate of 20 liters per minute. And this happens for 20 hours. All right. So let's convert this 20 hours into minutes. How do we do that? We multiply it by 60 because in 1 hour there are 60 minutes. So 20 times by 60 is going to give us 2 times by 6 is 12, and then add the 2 zeros. So it's 1,200 minutes. Okay, that's how long it's going to be for 20 hours. And 20 liters is going in every single minute. So now we're going to multiply this 20 by 1,200. So 2 times 12 is 24, and then add the 3 zeros, and you get this much volume. Okay, so this is how many liters is in the pool after 20 hours. 24,000 liters. Now, let's convert this into meters cubed. Why? Because all our measurements for the pool are in meters. So to convert this into meters cubed, we know that 1 meter cubed is 1,000 liters. So we can divide this by 1,000. So 24,000 divided by 1,000 is equal to, let's cancel the zeros, 24 meter cubed. So that's how much water is inside our tank. All right, now let's go back and look at our problem again. We need to work out the height here, okay? Now, we've worked out the volume of the water after 20 hours. Let's focus on this trapezium a little bit more, okay? This one, all right? So let's do another drawing of this. So here's H. We have this like that up to that level. Okay, so we've got this diagram right there. Let's focus on this height right there. Okay, so if we have, how do we find this height right here? Okay, we know that this is 2. Okay, we know that all of this is 2. We take away the 1.2 and we can find that. Okay, so this height right there is going to be 2 take away 1.2, and 2 take away 1.2 is 0.8 meters. So this here is 0.8 meters. All right, so we've got that. Now, if we draw the trapezium, because remember our H value, it may have risen higher than that. Okay, we can't assume that it's there. So we're going to go higher than that, and then that makes a trapezium. Can you see that? We're going to draw this trapezium now, like that. Okay, so this here I've done. This is still 0.8, which I've calculated. All right, and this is our H. And we know that this way from here to here is 10. Okay. So what we are doing here is we are working out the area of this cross sections. Then we're going to multiply it by the 5, which is the width that way, and that will give us the total amount of the volume. And we know the volume is 24, so therefore we can use that to find H afterwards. Okay, so bear with me. Hopefully you've understood what I've done so far. All right, now how do I work out the area of this trapezium? So area of trapezium, which is our cross section of our 3D shape. Okay, right, so area of a trapezium is the 2 parallel sides, this and that, divided by 2 times by the height, okay, which is 10. So what is this length right here? Well, we know that this is H, okay, because this is H right there. So we know that this is H. So if we do H take away 0.8, H take away 0.8, that will be just this. All right, so now we've got our 2 parallel sides. So A plus B divided by 2 times by H would be equal to our area of the cross section. All right, so let's get rid of that. So it's going to be A, which is H, plus the other parallel side, which is H minus 0.8. And we're going to divide that by 2 and times it by 10. All right, so that's what we're doing. So if we notice here, we can cancel those. So 10 divided by 2 is 5. So then we can collect the 2 H's here. So we've got 2H minus 0.8 times by 5. And then if we expand this out, so we do 2 times by 5, we get 10H. And we do 5 times by 0.8. So 5 times by 0.8. So we do 5 times by the 8, which is 40. And then we have to have 1 decimal place. So it's going to be just 4. So 5 times by 8, 0.8 is 4. So that is going to be minus 4. So this is an expression for the area of the cross section. All right, this. Now all I have to do is times it by 5 because I want to find the volume and I want to equate it to this 24. Okay, so the volume is going to be area of the cross section times by the length, if you like, okay, or the height, whatever width. Okay, so the volume I know is 24. The area of the cross section is 10H minus 4, and the length is 5. Now don't be confused with this 5. Okay, that 5 was done because 10 divided by 2 gave us 5. All right, that's to do with the area of the trapezium. This 5 is for calculating the volume and timesing it by the width. Okay, so don't be confused with that, please. So where do we go from here? Well, let's expand this first. So if we expand this up here, so we get 24 is equal to 10 times 5 is 50H, and 4 times 5 is 20. So we've got that. Let's take the 20 to the other side. So we've got 44 is equal to 50H, and therefore H would be equal to 44 divided by 50. And 44 divided by 50, if we work this out using long division, so 44 divided by 50, we know that 50 don't go into 44, so we put the decimal here and we go into 50? How many times does it go into 440? So it don't go into 44, so we put the decimal there. And into 440, it goes in 8 times. How I did that is just count up in 50s. 50, 100, 150, so on and so forth. It goes in exactly for 400, and for exactly 400, that's 8 50s, and remainder is 40. Okay, so again, you've got to now do how many times does 50 go into 40? Well, it doesn't, so you have to add a 0. So again, you got 50 into 400, and you know that goes in exactly 8 times. So the answer to 44 divided by 50 is 0.88 meters. And that is the height of your water after 20 hours. Hope you enjoyed this paper walkthrough. Make sure that you go over it again before your exams. Share it with your friends and other people so that they may benefit from it as well. And look out for papers 2 and 3. See you in the next video, guys. Bye for now.